So we have new methods utilized to deter African elephants from crop raiding in the Kasigau Wildlife Corridor in Kenya. Lynn Von Hagen.
Thank you, everyone, and again, good morning. I'm happy to be here, representative of my team that's working in the Kasigau Wildlife Corridor of Kenya, to introduce you to some of the new methods that we are testing and utilizing to prevent African elephant crop raiding. So the Elephants and Sustainable Agriculture in Kenya project is a large collaboration between Western Kentucky University, Jomo Kenyatta University in Nairobi, and my new institution at Auburn University in Alabama in the US, and our hosts in Kenya, which is Wildlife Works, which is one of the world's largest REDD++ UN-backed carbon initiatives. You can see the list of our team there on the screen. I think most of you probably know Dr. Schulte. And of course, we have a lot of gratitude for our participating farmers in the community of Sisenyi. So as you're all acutely aware, human-elephant conflict is a continuing problem that is only increasing. And in our area, we do have conflicts over water resources, but the majority of the problem comes through continued agricultural development, increasing populations of people, and takes the form of crop raiding. We do have an elephant population that is starting to expand and move into some of their historical areas. And with these interactions, there's a lot of negative outcomes. Farmers will try to take revenge against elephants, whether they know or not it was elephants, which creates lots of issues for elephant conservation. It can also be very dangerous. Farmers can be injured or even killed trying to defend their farms, and the same for elephants. And you can see we have an unfinished elephant population. You can see in the bottom some of the elephants, what they have to deal with to get to water resources, to move just from one of the parks over to one of the areas of refuge. They have to cross these entire settlements, one road, 2 railroads, and a lot of human activity. So for a while now, people in this community have been relying on traditional deterrent methods by building barriers such as fences or digging ditches, guarding on foot patrols such as this, or using dogs, and just generally using general fear of humans to try to deter elephants from crop raiding. And this is maybe going out making noises, banging pots and pans, or just running after elephants with a flashlight trying to scare them off. And while this may be a very cost-effective method for them, it's very energetically expensive. They may have to keep kids home from school to have them help guard against elephants, or they lose sleep or work. And most importantly, elephants will become used to these different type of methods over time. So in designing kind of the ideal deterrent, I've developed these 3 key factors that I believe are really important. And that goes, the first 2 go hand in hand, which are practicality and affordability. Rural farmers have very limited resources in the area that we work in. No running water, no electricity, very limited access to transportation. And as far as the affordable part, most cannot invest any money into deterrents. Many are subsistence farmers. Poverty is very high in this region. And kind of the final and most important key to designing a good deterrent method is resistance to habituation. We all know exactly how smart elephants are. Most things, unless they have some type of recurring negative stimulus, elephants will simply get used to them and be able to overcome them. So we want to use what we know about elephant behavior in designing new methods. We want to be able to send a signal or a message to the elephant that if you are going to undertake this behavior of crop raiding, come into this area, it's either going to be energetically expensive, takes too much time to get around, or it might cause some time of harm or discomfort. So for a while now, people have been using this to devise more modern deterrents that use these kind of behavioral constructs to create negative recurring stimulus, because that's what it really takes for an elephant to be able to use their memory to to be able to remember all these different aspects through different modalities of why undertaking this behavior is not going to be beneficial. So some of the more modern deterrent methods are incorporating this type of system, such as chili peppers, beehive fences, electric fences. So for example, with beehive fences, an elephant can see the swinging boxes in the field, they can hear the bees, they can smell the honey. So you've got a lot of senses that are stimulated, so if they undertake the behavior, then there's a negative association with those senses. So what our project wanted to do was simultaneously test several different deterrent methods to decide which was the most effective in this area. We selected a traditional acacia fence. We also tested chili fences, a new metal strip fence, which was kind of the onus of this project, and then a combination of two different deterrent methods, a chili fence plus a metal fence. And I'm going to talk a little bit more about each one of these. The predominant crop in our area is maize, which elephants really love. So that is what we planted in our experimental fields. So the hypothesis was that the combined deterrent methods, such as the chili plus metal fence, would be the most effective, followed by the standalone but yet multimodal fences of chili or metal strip fences, and then lastly the acacia fence. So the location that we're working in Kenya is the Kasigau Wildlife Corridor. Now that lies between Tsavo East and Tsavo West National Parks. You can see here, the corridor lies in between. We've been working specifically in Rukinga Ranch there. This is an area of high human-elephant conflict, and it's home to the country's largest elephant population of over 12,000 individuals, which is slowly and thankfully increasing. So for the experimental design for the project, you can see up here at the top, it's one of the basic blocks. We created 4 different blocks. We randomized the different deterrent types. We took our 4 deterrent types and paired them each with a control. So we had a total of 8 experimental fields. In between each one, we left an open area so that elephants or people could cross in between. When we created these 4 experimental blocks with our volunteer teams, the project is an Earthwatch Institute team, so we have volunteer citizen scientists coming 6 times a year to help us out with the experiment. So the first deterrent method that I want to talk about is kind of the focus of the presentation, which is a metal strip or a Kasaine fence. It's named after its inventor, Mr. Simon Kasaine, who is a collaborator with us and works as a research scientist at Wildlife Works, and who has been living in this area all his life. So to create this fence, what you do is you take Mabati metal, which you're probably all familiar with. That's a lot of the metal sheets, or people often call them iron sheets, which are used on top of houses. So it's a very lightweight metal. You can cut these into small strips, put a hole in the top, and then you string them on a flexible wire. Now it's very important that you put crimps in the wire about every foot or so that the pieces don't slide together in the center, because then the fence doesn't work. And I have a little video that I brought so you can kind of see the sound that it makes. We got to get you a little sound, sorry. All right, let's try that again. So imagine being an elephant and encountering this noise in the middle of the night. Now we're very lucky that in the area that we're working in is very windy. So this fence, anytime you contact it or anytime the wind blows, will kind of go off and make this noise. Working from the principle that it's an intermittent noise. So it can be completely quiet, and then all of a sudden the wind blows and elephants around, and then all of a sudden there's noise. We think this perhaps makes them think that people are around. Also, the fence is highly reflective, so it might be a bit of a visual stimuli on a moonlit night. And so, as I mentioned, with each deterrent method, we did an entire field of a paired control. So the control method for this one was just a simple wire with the crimps that I mentioned in each field. Oh, there it goes. Okay, the second method we tested simultaneously, you're probably more familiar with, is a chili pepper fence. And this is where you crush up find the hottest local peppers you can, crush them up with a mortar and pestle, make sure you wear protective eyewear. I promise you, you do not want this to get into your eyes. And then you mix it with used motor oil. You take cloths and ropes, you dip this into the mixture, and then you erect this in panels around whatever you're trying to protect. This is kind of what the finished product looks like. And it ends up being about elephant height. So this noxious odor, as chili peppers do in most animals, stimulates the trigeminal nerve, so you'll get mucus production, watering eyes. Very similar to pepper spray, so it's a very unpleasant odor. Now for the paired control for this deterrent method was just a motor oil only fence. because we really wanted to test and see if it was the chili peppers themselves that had held the majority of the deterrent power, or if it was actually the motor oil or the movement of the flags that also contributed to success. As this has been fairly successful across different areas in Africa and Asia, depending on locality. And then our third deterrent method type was a combined chili plus metal fence. This is the same same construction method. We just simply separated them a little bit more with the chili fence on top and the metal strip on the bottom. The control for this method was, again, just the motor oil only fence. It still had the cloth and just the wire with the crimps, no metal strips. And then our last deterrent method was the acacia fence. Acacia has been used for generations to either keep, as in bomas, to either keep predators out, protect their cattle, or to keep other people's livestock from coming into farms. So the acacia fence we put around each different individual field, and very important for this method was the control for this, which was no deterrent method, and served as our master control for the experiment. So as you're flying over the block here, you get a little bit better visual of the layout. So the road in between here is the dividing line between Rukinga Ranch and the community. Very high crop rating here. And we set these 4 blocks out kind of in a line so that we could protect as much area as we could. We used community monitors in addition to our team, as well as over 30 camera traps to monitor elephant approaches and breaches through the different fences. You can see the chili flags there in the meadow kind of reflecting in the wind. And you may notice that our farmers lived right next to the experimental area. This did not end up being a confounding factor, as most of you have talked about before. Elephants do just come right up to people's homes in this area. So what did we find? You can see in this results table here, we have this broken down in 50-meter increments. These were the times that elephants approached different types of deterrent methods and where we were able actually to detect them. 419 visits to the different farms we found. And we considered an approach is when they came up to the farms and actually did not break in. A successful raid was when an elephant was able to overcome the deterrent methods. Now we analyzed these at 25 meters or less with the Fisher's exact test. As you would expect, there's some natural limitations to doing a study like this because it's just by chance when the elephants decide to come and where they decide to walk up to. And you can see that we can much more easily detect them at 50 meters or less. So this is just kind of a one-shot results table I'll briefly kind of walk you through. We did see that 33% of the time that elephants came, they were able to overcome the different methods, which was 16% of the times. And here the blue bars are the different deterrent methods. You can see the titles here at the bottom and the sample sizes. And we did find that the combined chili plus metal fence and the standalone metal fence did demonstrate a statistically significant deterrent effect. And you can see here the different deterrent types as the efficacy does decrease with the fences. You can naturally see this brown line shows that the number of successful raids did increase. And you can see just barely this picture at the bottom is one of the shots from our camera traps. Time and time again, we would see elephants walk up to this fence, look at it, and simply turn away. And we did have a lot of surprises with our study, as probably most everyone does. The chili fence performed really poorly for us. It was about 7th place in our deterrent methods. We can see elephants commonly walking around with the chili grease on their head. We do believe that is probably due to the fact that we were in a very windy environment, that we did stick with the protocols. So that also just demonstrates that not every deterrent method is going to be successful in every area. Elephants reacted to the metal control, as you can see in the top camera image here. That, again, I'll remind you, is just a simple wire, nothing more. Elephants did break it often, so it wasn't enough to suggest it as a deterrent method. But time and time again, we would see things like them reaching underneath if they could see it, or if they would come up in contact it, they would immediately run away. So we do think that perhaps they thought this was an electric fence, which indeed was not. But it's also like a last-ditch effort you might suggest to farmers if they have very limited income or unable to afford any kind of deterrent methods. And then lastly, we saw that eland presence was really substantial in our area. There's a real paucity of literature of elands as being any kind of substantial crop raiders. But on some, we did this over 2 trials. Some of the trials we saw them in the farms as often as elephants. People were aware that elands were in their community, but they pretty much blamed everything on elephants. So it seems that there's definitely a disconnect here between perceptions of who the crop raiders are and who some of them might actually be. So kind of going back to this ideal triangle with the Kasigau or metal strip fence, we see that it's very practical. There is some construction in the beginning, but once you erect it, it's really completely maintenance-free. If it's broken, all you do is pick it up, twist the wires back together. So farmer investment in the beginning is heavy, but after the fence is up, you really just do nothing with it. It does come in somewhat affordable, anywhere from 34 cents to $1 per meter, depending on how elaborate you get with your poles, whether you treat them for termites, whether you forage poles or things like that. And most importantly is resistance to habituation. This is an ongoing study. We're continuing to test this fence. Thus far, fingers crossed, we have seen no habituation. That may be due to the fact that we have a very transient elephant population. We do have some recurring raiders, but we might not be seeing the same elephants. But it's definitely something we're keeping our eye on. But thus far, we've had very few incursions into this fence over the subsequent trials. So next for our project, it is ongoing. We're testing beehive fences, had good success rates so far. We've since started a double Kasigau fence, which is just the metal fence, which is a double layer. And the great thing about this project is we validated our experimental design. We saw equal approaches to all the different deterrent types. So this kind of sets it up to where you can switch out deterrent methods and be testing different things if you have new things that are being developed. So next for me, as I move into my PhD work, is I'm going to be developing community workshop programs with the community to be able to bring address 5 different key drivers of problems that we see with human-elephant conflict. Lack of access to deterrent methods or information on how to build them, support from the community, initiatives that encourage sustainable livelihoods because poverty is making crop raiding worse. That people in this area really don't know the best practices for living amongst elephants, nor do they really understand their vital role to the ecosystem, which goes hand in hand with conservation education, as well as introducing climate-smart agricultural practices so that crop yields will be more effective. Many people to thank for this project, especially the International Elephant Foundation, which has allowed me to be on the ground for almost 2 years doing this wonderful work. And I don't have time for questions.